Today we're going to start graphing logarithmic functions. Now we're going to write the parent function or the standard form of a logarithmic function. So y equals, and you'll notice that we have our a, h, and k value back like we had with all of our other functions. And that is kind of the benefit of having these functions written this way, because every time we get a new function to learn about, the a, h, and k are going to do the exact same thing. Okay, so like we've known before, the a value, that gives us a vertical shrink or stretch. Shrink or stretch. It also tells us if we have a reflection or not. Then our h value, that tells us our horizontal shift. And just like we talked about before, your horizontal shift is going to be the opposite of what you see. X minus 5 means you are shifted right 5. And your k value is your vertical shift. Now the table that we're going to have here, the tables are going to be pretty simple. You have x, y, and we're going to have 2 points. 1, 0, and then your base, whatever your base is, your base, 1. That's it. Those are the only 2 points that we are going to plot in our logarithmic function. So let's look at this graph right here, and we see that it's y equals log base 4 of x. We're asked for the transformations. Reflection, there is none because there's no negative sign in front. Shrink or stretch, there's also no shrink or stretch. And there's no translation. Now when we do our table, we do x, y, and we're going to have the point 1, 0, and then our base here, our base is 4. So 4, 1 is going to be our other point. So let's plot those. 1, 0, and 4, 1. Now you see the word asymptote here, and that should bring back memories of graphing your exponential functions where we had an asymptote. We had a horizontal asymptote. Well, remember that logs and exponents, logs and exponential functions are inverses of each other. And when you find the inverse of a function, you switch x and y. So in the exponential functions, our asymptote was horizontal and the equation was y equals a number. Well, if we're switching x and y, then it should make sense that our asymptote in logarithmic functions is going to be x equals a number, and it's going to be a vertical line. In exponential functions, we had a horizontal asymptote, and the equation was y equals a number. In logarithmic functions, we're going to have a vertical asymptote, and x equals a number. Our vertical asymptote will always start at x equals 0. And this is how we're going to draw it to kind of help you not cross it. We use a dotted line. So our asymptote is at x equals 0. So now when I graph this, I got to make sure I don't cross my asymptote. So my graph will look something like that. Let's draw this a little bit nicer. So our asymptote is x equals 0. Now the end behavior. Up until now, we've always had as x goes to negative infinity and as x goes to positive infinity. But if you look at the graph here, x never goes to positive infinity. X never reaches 0. Our x values never actually get to 0. So that means instead of saying the left side goes to infinity, we're saying that the left side goes to 0. And we still have the right side going to infinity. So what's happening here is that the left side, as we get closer and closer to 0, the y values are going down. And if we look at the right side of this function, as x gets larger and larger, the y values are getting larger, but very slowly, but they're still getting larger. So then domain and range, your domain and range is going to be 0, infinity, because those are the x values we have. And our range is going to be negative infinity, infinity. We hit all y values, but we don't hit all x values. And you'll notice that these all match up. That's how you can tell that you're doing this right. Now, number 2 here, we don't see a base. Remember, if we don't see a base, it's an invisible 10. Okay, so now we can make a table. This question isn't asking us for the transformations. It's just asking us for the asymptote, end behavior, and domain and range. Well, we know that the point 1, 0 is going to be on the graph, and the base, 1 is going to be on the graph. So let's plot that. 1, 0, and 10, 1. And our asymptote is still going to be at x equals 0. So then our graph will look like this. So then our end behavior, as x approaches 0, because that's my asymptote, my y value is going down towards negative infinity. And as x goes to positive infinity, the y values are also going to positive infinity. The right side has the y values going up. Domain of this is going to be 0, infinity. And the range is going to be negative infinity, infinity. And again, all of these match up. They're all 0. Now, remember when we talked about exponential functions, we said that the domain was always going to be negative infinity, infinity. Well, since the logarithmic function is the inverse of an exponential function, and inverses are when your x's and y switch, that should it should make sense that our range of logs will always be negative infinity, infinity, because the domain of exponents, the exponential functions, was negative infinity, infinity, and we switched them. We switched the x and y's. So this was just to introduce graphing logarithmic functions and allowing you to see that there are some major differences between the other functions we graphed. Most of all the other functions we've graphed, the domain was negative infinity, infinity. Now we have, a domain that isn't like that. We also have an end behavior that doesn't go to negative infinity. We have a vertical asymptote. So there are a lot of new things about this one, but at least the table is simple for us to fill out. So thank you for watching. Make sure to like the video and subscribe.